Welcome to this recorded webinar on the control of hazardous energy, or, as it's more commonly known, lockout tagout in general industry. After this video, you will be able to understand why energy control procedures are needed, identify the different methods of lockout tagout, be aware of the employer's responsibilities as well as the requirements of employee training, and finally, understand how to handle lockout tagout for situations to include group lockout tagout with outside contractors, and with shift changes. North Carolina has created a special emphasis program with a focus on reducing the occupational occurrence of amputations in North Carolina. Now, why is this being mentioned in a webinar on lockout tagout, you ask? Well, unfortunately, the lack of or incorrect use of lockout tagout has led to employees suffering amputation injuries. This SEP seeks to increase employer and employee knowledge of the hazard of amputation by providing training events, consultation visits, and compliance visits. In addition, the North Carolina Department of Labor online publications, which address this and other hazards, can be found at our website at www.labor.nc.gov. Just a reminder, any amputations as a result of a work-related incident must be reported to OSHA within 24 hours. So what is lockout tagout anyway? As I mentioned previously, it's officially known as the control of hazardous energy, but that's a mouthful, so you can see why it mostly goes by lockout tagout or even just the acronym of LOTO. The OSHA standard for lockout tagout, found in 1910-147, establishes the minimum requirements for the control of hazardous energy when an unexpected startup or release of stored energy could cause injury to employees. Now let's look at the scope of this standard. Now, this standard covers the servicing and or maintenance of equipment where, if the equipment being worked or serviced could unexpectedly start up or release stored energy, it might injure the employees doing the work. Now, servicing and or maintenance, what does that mean? What's included in these activities? Well, the activities would include when employees are constructing, installing, setting up equipment, inspecting, modifying, maintaining, and or servicing machines or equipment. Now, these activities can include tasks such as lubrication, cleaning, or even unjamming of machines or equipment, and making minor adjustments or tool changes. Now, these tasks are not considered a part of normal production. In 1910-147C1, it explicitly states that before any employee can perform these servicing and maintenance duties where the unexpected release of stored energy is a hazard, the equipment or machinery must be isolated from the energy source and rendered inoperative. It's important to understand when lockout tagout has to be applied. It's to be used when employees are servicing and maintaining equipment and machinery. Lockout tagout requirements are not typically required during normal production operations, except when an employee is required to bypass or remove a safety device and so expose themselves to a hazard, or it's required if an employee is near the point of operation or the danger zones of the equipment. Now, you see the phrase normal production operations used in the standard. What's meant by that? Well, using machines and equipment to perform its intended production function. That's normal production operations. I want to talk about this. Employers have sometimes misinterpreted this part of the standard. It is true that regular production tasks do not typically fall under lockout tagout. If an employee is ever required to place any part of their body into moving machinery or the point of operation or any other danger zone that exists, lockout tagout will still need to be used. Remember, it's all about keeping the employees safe from harm. Like in every standard, there is always an exception. Let's look at the minor servicing exception. This is an often misunderstood part of the lockout tagout standard. Now, this minor servicing exception applies only to minor servicing activities that must be performed during normal production. These servicing activities must be necessary to allow production to proceed without interruption. Now, the minor servicing activity has to fulfill 3 requirements in order to qualify for the exemption. 1, it must be routine. That means it's performed as a part of a regular basic course of procedure. 2, it must be repetitive. It means it's repeated regularly as a part of the normal production process or cycle. And it has to be integral. That means it is inherent and necessary to the production process. Now, if the task meets the requirements of the exception, there's still just one more thing that must be taken into account, and that is the safety of the employee. The exception only applies if the employee is provided with effective alternative protection from hazardous energy. So for lockout tagout to not be used for these activities, the employees must be protected from hazardous energy by means that work at least as well as lockout tagout would. Now, this is where issues can occur. If alternative lockout tagout measures are not or cannot be applied, then the activity does not fall under the minor tool changes and adjustment exception. The application of this standard does not cover normal production operations, and we've already looked at that. Hot tap operations under specific special conditions, and it also doesn't apply to cord and plug connected equipment. Now, why would lockout tagout not apply to cord and plug connected equipment? Well, because to control it, you just have to unplug it, right? As long as the plug is under the sole control of the individual doing the work. Let's say there are circumstances where an individual can't control the plug. Is there a way you can lock it out? Well, yes, there are. There's lots of devices available that will fit around a plug that will also accommodate a lock. Let's take a look at some definitions. There are 3 different types of employees that relate to lockout tagout. First, let's look at the authorized employee. This is someone who is authorized to lock out or tag out equipment in addition to performing the actual work. These are your main employees that the lockout tagout procedure is supposed to protect. Affected employee. Now, this is an employee performing duties on equipment or working in an area where an energy control procedure is being implemented. This is on which servicing and maintenance operations are being performed. Now, these affected employees can become authorized employees if their duties require them to perform the servicing or maintenance tasks on the equipment. Other employees. These are employees who might be working in and around the areas where an energy control procedure might be utilized. Now, these employees must be instructed about the energy control procedure and about the prohibition about restarting or re-energizing machines and equipment which are locked out or tagged out. Now, why would training these employees be important? Well, it's because accidents happen. Employees need to know so they don't accidentally place someone in danger by, say, flipping a switch. There was a real-life incident which involved a front office employee. They entered the production floor, flipped a switch that was usually on, and it resulted in a worker death. Another definition we need to look at is hazardous energy. What is hazardous energy? Well, there are many different energy sources, including electrical, mechanical, hydraulic, pneumatic, chemical, thermal, and other sources in machines and equipment that can be hazardous to workers. Additionally, workers need to be aware that there can be a combination of energy sources within a system as well. For example, you may unplug a portable air compressor, but if the air is not isolated from the pneumatic nail gun, that gun can still go off and fire a nail. Now, this would be an example of where the hazardous energy that's needed to be controlled included both electrical and pneumatic energy. Let's review each of the different energy sources listed here briefly. First, mechanical energy. This is the energy which is possessed by an object due to its motion or due to its position. A good example of potential mechanical energy is a guillotine. Kinetic energy is extra energy within an object due to its motion. This is the basis of many caught in, caught between, and caught on accidents. This often involves flywheels, shafts, and clutches. Hydraulic energy. This is power created by the compressive force or movement of a liquid in a confined area. An example would be a hydraulic jack. Pneumatic energy. This is power created by the compressive force or movement of air or gas in a confined area. Assembly tools often use pneumatic energy to force parts together. You'll see this in presses, vices, pneumatic nail guns, and other pneumatic tools that are all air-driven. Electrical energy. This is power stored in an electric field or transported by an electric current. This is the most common form of energy, and it's the most common associated with lockout. An example would be isolating a plug, locking out a circuit breaker, or locking out a service disconnect. Thermal energy. Now this is the energy that manifests itself as an increase of temperature. It is associated with both hot and cold systems and the transfer of this energy through particles. Hazards associated with thermal energy are burns, heat stress, and frozen tissue. For example, a hot surface like a hot break will transfer that heat energy to your cooler tissue and burn it. Likewise, the heat from your tissue will flow from your skin to a cold surface, and this can cause your tissue to freeze. Chemical energy. This is energy stored in the bonds of atoms and molecules. It's the energy that holds these particles together. Biomass, petroleum, natural gas, and propane are all examples of stored chemical energy. OSHA requires an energy control program if the potential for employee exposure to hazardous energy exists. Now, the program has three core components. First up, energy control procedures. These procedures are to detail and document the specific information that an authorized employee must know in order to ensure that hazardous energy sources are isolated and rendered safe before any servicing or maintenance tasks are performed. Employee training is also a very important part of an energy control program. The employer is required to provide effective training for all employees covered by the Lockout Tagout standard and ensure that all employees understand the purpose, function, and restrictions of the energy control program. The program must also undergo periodic inspections to ensure that the procedures of the program are being followed as well as the requirements of the standard are being met. Now we'll look at each of these requirements in a little more detail in future slides. Now, if the energy isolating device is not capable of being locked out, the employer must use a tagout system. Now, tagout is when a tag is placed on a piece of equipment. This tag just indicates that the equipment being controlled must not be operated until the tagout device, the tag, is removed by the person who placed it there or other authorized individual. On the slide, you can see an example of a tag. So, we've been throwing around the phrase energy isolating device. It gets mentioned in the standard a lot. So exactly what is it? An energy isolating device is an actual mechanical device that physically prevents the equipment from being restarted. It prevents the release of energy. An example would be a manually operated electrical circuit breaker or a disconnect switch. Keep in mind, push buttons, selector switches, and other control circuit type devices are not energy isolation devices. Of note, tags simply warn employees against re-energizing devices while they're being serviced. These tags are much easier to remove or circumvent than locks and do not provide the same level of protection. If possible, lockout must be used. An employer cannot just choose to use tagout because it's more convenient. What if a tagout device is used when a lockout device was capable of being used? Is this allowed? According to the standard, it is allowed. However, certain conditions must be in place. The tags must be attached where the lockout device would be placed, and the employer must demonstrate that the level of protection achieved using the tagout program is equivalent to the level of protection provided by a lock. You might ask, how can you ensure this? The employer must comply with all tagout related provisions of the standard and use additional safety measures that provide a level of safety on par with lockout. Now, this will depend on the specifics of the equipment or the task being performed. An example might include removing a valve handle to reduce the potential for accidental energization while the tags are in use. So let's move on to energy control procedures. So procedures for equipment with one or more sources of energy must detail the scope, purpose, authorization, rules, and techniques that the employer will use to control that hazardous energy. The scope might be limited to a single or a group of similar pieces of equipment or machinery. Now, the purpose of the procedures is to ensure the unexpected energization, startup, or shutdown does not occur during servicing or maintenance activities. Now, the authority. The responsible manager authorizes the procedures and ensures specific rules and techniques are listed within the procedures. The procedures must state the means to be used to enforce compliance. Typically, this requirement is met by stating the procedure is mandatory and may result in disciplinary action if not followed. At a minimum, the procedures must include a statement of the intended use of the procedure, steps for shutting down, isolating, blocking, and securing the equipment, steps for the placement, removal, and transfer of lockout devices, and test methods to verify equipment has reached a safe zero energy state. Here you can see listed the basic steps of an energy control procedure. 1. A statement of the purpose of the procedure. This is its intended use. 2. This is the specific steps required to control any and all forms of hazardous energy. 3. The steps for the placement, removal, and transfer of lockout or tagout devices, as well as who is responsible for ensuring their placement and removal. 4. Finally, you've got the requirements for verifying de-energization or otherwise determining the effectiveness of the lockout tagout devices and other energy control procedures. Now, there is an exception to the procedure. So documenting the energy control or lockout tagout procedure is not required if the employer can verify all of the exceptions. Now, there's a total of 8. They have to show that there is no potential for stored or residual energy, that there is only a single source of energy which is readily identified and isolated. They also need to be able to isolate and lock out energy completely de-energizing the equipment. And the equipment must be isolated from energy and locked out during servicing. But wait, there's more you have to ensure. Let's go on to the next slide. So to continue, you don't have to document the procedure. It's not required if the lockout device is under the exclusive control of that authorized employee. Servicing does not create hazards for other employees, and the employer has had no accidents relating to lockout tagout. Again, if the employer can't meet all of these 8 exceptions, written lockout tagout procedures must be developed and used. Here is a list of shalls for lockout tagout materials and hardware. What this means is that according to the OSHA standards, you gotta have this. Lockout tagout devices must be provided by the employer. They must be singularly identified. Each one must have a unique key, and that's one employee to use the lock, and that's the only one who has the key. The devices used must only be used for controlling energy. They cannot be used for any other purposes. So here we go. The list of shalls continues. Lockout and tagout devices, again, must meet this criteria. They have to be durable. Lockout devices must work properly under the environmental conditions in which they are used. Warnings on tagout devices must be legible, even in wet, damp, or corrosive conditions. They must be standardized. That means lockout and tagout devices must be designated by color, shape, or size. Tagout devices must have a standardized print and warning format. The locks must be substantial. Lockout devices and tagout devices must be strong enough that they cannot be removed inadvertently. Tagout devices must be attached with a single-use, self-locking material, such as a nylon cable tie, with a minimum unlocking strength of 50 pounds. Let's do a little hazard recognition. Take a look at this lock. Would you say this is identifiable? Take a second. No. Based on the photo, there is no personal information recorded on the lock. If the name and date were on the lock, it would be identifiable. A tag is not required with the lock as long as the lock is proper for lockout and identifiable. Let's look at the requirements for periodic inspections. We'll be reviewing these over the next 2 slides. Now, periodic inspections help employers discover and correct program deficiencies. An inspection of each energy control procedure must be completed at least annually by an authorized employee who understands the procedure, but is not one of the employees who uses the energy control procedure as a part of their regular job duties. Inspections of energy control procedures can be scheduled or just random audits. A successful inspection confirms that the energy control procedure is correct and being followed by the employees, that the energy control procedure addresses all the energy sources, ensures that employees understand the energy control procedure and their related responsibilities. Now, the employer must certify, now that means document and sign, that the inspection has been performed. Who do you think might ask for a lockout tagout certification? If you guessed compliance officers, you are correct. For any inspections that involve lockout tagout, these are going to be asked for and reviewed. If they are not compliant and up to date, it could become a citation. Periodic inspections of lockout procedures must include a review of the authorized employee's responsibilities under the energy control procedures being inspected. The inspector must be someone who is familiar with the procedures and the requirements of the lockout tagout, but does not perform them on a regular basis to avoid any unintentional biases. Now, periodic inspections of tagout procedures are the exact same way. They must include a review of the procedure that an authorized employee must employ. However, the inspector must also review with the affected employees their responsibility under the energy control procedures being inspected. Again, the inspector must be familiar with the tagout requirements and procedures, but not perform them on a regular basis. Training and communication are vital for any lockout tagout program. Employers are required to train their workers on the purpose and function of an energy control program to ensure that employees have the knowledge and skills to safely apply lockout tagout. Training must include, for authorized employees, the recognition of hazardous energy, the type and magnitude of energy, and methods for energy isolation. For affected employees, the training must include the purpose and use of energy control procedures specifically for affected employees. Training and communication for all other employees. Now, these are the employees whose work may be in the area of energy control procedures being performed, but they're not the ones doing the work. They need to be trained in the procedures for energy control, be able to recognize lockout tagout, but not be required to perform the procedure, and understand and follow the prohibition for restarting machines that are locked out. Moreover, these other employees need to understand the importance of the lockout tagout device. What does it mean? And understand the seriousness. What are the dangers and the consequences to workers if the equipment or machines are restarted? Employees must also be trained on the limitations of tagout systems. We know that lockout devices provide a physical restraint to prevent an energy control device from being moved or switched into the on position. However, as mentioned before, tagouts do not provide that level of restraint. Tagout has limitations which need to be understood. Tagout systems are for warning only. There is no physical restraint. They must not be removed, bypassed, or ignored, ever. The tags must be legible and understandable. They must be able to withstand environmental conditions and must be securely attached. They cannot just accidentally fall off. One concern with tagout systems is that they may evoke a false sense of security, so their meaning must be understood. Retraining for authorized and affected employees is required if there is a change in job assignments. For an example, an affected employee becomes an authorized employee. Change in machines or processes that present new hazards to the employees. Changes in energy control procedures. And when periodic inspections reveal deviations or deficiencies in employee knowledge or procedures. Let's take a look at this setup. Is this a proper lockout? I'll give you a quick second to think about it. No, it's not. Here we have the improper use of a lockout hasp and no lock is being used. The energy source is not locked out and the tag does not identify the authorized employee. In this case, the tagout is incorrect, non-compliant, and ineffective. Energy isolation. Lockout tagout must only be performed by authorized employees. Now those are those performing the servicing and maintenance tasks. So let's look at the lockout in this photo. Does this look compliant? Yes. It appears that a single purpose lock is secured to the disconnect and the tag identifies the authorized employee. So this appears to be a good lockout. Communication is an important component of the lockout tagout program, be it in the form of training or of notification to employees. Now, affected employees must be notified by the employer or authorized employee before any lockout tagout controls are applied and after they are removed. To control hazardous energy, you must prevent it from being transmitted from its source to the equipment that it powers. You can accomplish this by following or applying the lockout control sequence. Now we're going to look at each of these steps in the upcoming slides. Step 1, preparation for shutdown. The employee must know the type and amount of energy, know the hazards of that energy, and know the methods or means to control the energy. For example, the type of energy is electrical. This can be either in current or stored, such as in a capacitor. The hazard is that contact with electrical energy can cause burns, shocks, and even electrocution. The means to control would be to isolate at the energy source. In our example, they could de-energize stored electrical energy in the capacitors. Step 2, machine or equipment shutdown. You want to turn off or shut down equipment following established procedures. Stop buttons and on-off switches are often used to shut down equipment. However, it's important to know that turning off the equipment does not separate the equipment from its energy sources. The method you use to de-energize equipment depends on the types of energy and the means to control it. After the equipment has been shut down, engage the equipment's energy isolating devices, physically separating the equipment from the energy. For compressed air, this could mean closing a specific manually operated valve. For an electric motor, this could mean opening a manually operated circuit breaker. Step 3, machine or equipment isolation. Now, all energy isolating devices that are necessary to control energy must be located and operated so that the machine or equipment is isolated from the energy sources. So a quick review. What is an energy isolating device? Remember, this is a mechanical device that physically prevents the transmission or release of energy. Step 4 is lockout or tagout application. Now this can only be performed by authorized employees. They are the only ones who can affix lockout or tagout devices. Lockout tagout devices must be used so that they hold the energy isolating device in the safe or off position. Now tagout devices when used must indicate that moving the energy isolating device from the safe or off position is prohibited. Step 5 is the release of stored energy. After lockout/tagout devices have been correctly applied, all potentially hazardous energy must be released or safely dissipated. Energy isolation is achieved when there is no energy left to be released. Step 6 is to verify that the lockout or tagout is effective. It's your last chance. Verification means purposely confirming that the equipment is separated from its energy source. Therefore, it is isolated. The authorized employee must verify that the equipment has been properly turned off or shut down. They must verify that energy isolating devices were identified and used to effectively isolate the energy. Individual lockout or tagout devices have been attached to the energy isolating devices, and stored energy has been removed or controlled. So you finished working on the equipment. What do you do next? Well, now it's time to release the equipment from lockout/tagout. Let's review the steps. Step 1, inspect the work area. The work area must be inspected by the authorized person to ensure that any non-essential items, such as tools or spare parts, have been removed and that all the machines or equipment components are operationally intact. The work area must then be checked to ensure all workers have been safely positioned or have cleared the area. In addition, all affected workers must be notified that the lockout or tagout devices have been removed before the equipment is started. Step 2, lockout/tagout device removal. Each lockout or tagout device must be removed from the energy isolating device by the employee who applied the device. As usual, there's an exception to this rule, and let's look at that in the next slide. If the authorized employee who applied the lockout/tagout device is not available, the employer may have it removed as long as they verify that the authorized employee who applied the device is not at the facility. They must also make all reasonable efforts to contact that authorized employee to inform him or her that the lockout or tagout device has been removed, and ensure that the authorized employee knows that the lockout device has been removed before he or she resumes work at the facility. In some circumstances, workers need to temporarily restore energy to a machine or a piece of equipment during a servicing or maintenance task to test or reposition the machine or piece of equipment. Now, lockout or tagout devices may be removed temporarily in order to perform these tasks. However, it's important to know that you may not use an abbreviated procedure during the release, test, or restore sequence. You must use full lockout/tagout procedures anytime you release from lockout/tagout or restore equipment after testing and positioning. If you have outside personnel, such as contractors coming on site, they must be informed of your company's lockout/tagout procedures, and your company must be informed of theirs. The on-site employer must ensure that employees understand and comply with the restrictions and prohibitions of the outside employer's energy control program. A group of authorized employees may need to service equipment that has several energy sources and several energy isolating devices. To effectively ensure lockout/tagout, group lockout may need to be performed. Under the standard's group lockout/tagout requirements, a single authorized employee must assume the overall responsibility for the control of hazardous energy for all members of the group while the servicing or maintenance work is in progress. The authorized employee with the overall responsibility must implement the energy control procedures, communicate the purpose of the operation to the servicing and maintenance employees, coordinate the operation, and ensure that all procedural steps have been properly completed. If you have shift or personnel changes, how is the continuity of lockout or tagout protection to be maintained? Well, employers must ensure the continuity of employee protection by providing for the orderly transfer of lockout or tagout device protection between outgoing and incoming employees. This will help to minimize exposure to hazards from the unexpected startup of the machine or equipment or the release of stored energy. Now, a shift change procedure could be if a lockout procedure will extend into the following shift. The employer will usually require the authorized employee who originally placed the lock to remove it. Then the ongoing authorized employee will then immediately replace their lock and continue the repair or maintenance on that equipment or machine for that following shift. If you'll look in Appendix A in the 1910-147 standard, you'll find non-mandatory guidelines to assist employers and employees in complying with the requirements of the Lockout-Tagout standard, as well as a lot of other helpful information. Now, nothing in the appendix adds to or detracts from any of the requirements of this section. Also, you should check out the labor.nc.gov website. We have additional materials there that you might find helpful, such as a copy of this presentation and sample lockout-tagout programs. And we've come to the end of our presentation. In this course, we've looked at the reasons why we need energy control procedures, the methods for lockout-tagout, the employer and the employee responsibilities, as well as employee training needs. We've also looked at the inspection requirements for lockout and tagout. Thank you for watching our video on the control of hazardous energy or lockout-tagout. If you have any questions, our contact information is listed here on this slide. Please visit our website at www.labor.nc.gov for access to sample programs, training PowerPoints, and even training, which you can register for at our training calendar. Have a great day.